Now I'm going to deal with the logical vectors in R. Right? We have looked at performing different kinds of functions and calculations on the numbers. Even within that numbers, we have looked at some special numbers like infinite, minus infinite kind of stuff. But in some cases, we are required to perform some calculations that involve the logical values also, wherein I talk about some kind of relational operators, less than, greater than, less than or equal to, greater than or equal to, not equal to, some such kind of relation operators. Or probably I can even talk about using the major relation operators like not, and, or. So different kinds of relation operators also, where we talk about they evaluate to Boolean, right? Any such kind of a function evaluates to either true or false. So these are the ones which we are calling as relational or logical kind of operators. But when we talk about R, there are three outcomes that are possible. Probably there is a true, there is a false, and also there is an NA. So in some cases even an NA can come out, which means it's just not two outcomes here, it's not Boolean. There are three outcomes that are possible. And as I have already mentioned earlier, true and false are the reserved keywords. So I cannot create any kind of variable with those names true and false. Similarly with T and F, right, there is a kind, though they are not reserved keywords, they are defined as true and false only. Now, the most important thing is using the different kinds of logical operators. As I have already talked about, one is the not, I have the and I have the piping symbol which is for or. And even these are vectorized, right? Just like the various arithmetic operators, even the logical operators are also more and more vectorized. So what we'll do is, I just want to do some kind of assignment of values and then try out all these combination, right? I simply want to assign some values. Let's say one, I have to assign the values 1 to 10 to x, right? I want to assign the values 1 to 10 to x, and I really want to see whether they are less than or equal to 5, and I wanted that to be printed as well, so I'll say semicolon x. So it says that the first 5 values are true and the next 5 values are false, because 1 to 10, they are 5 of them are less than or equal to 5, the next 5 of them are not less than or equal to 5. Similarly, I am doing one more assignment. Let's say y. I'll say 1 to 10. Let me do an integer division, or probably let me do the remainder, whatever it is, right? Let me do the integer division or probably the remainder. So let me say remainder, when I divide by 2, I want to equate it to 0, and I want to print this y. Either I can print it, or as we have discussed earlier, this entire thing I can enclose it in a bracket which will print. Okay, the first one is false, 1 divided by 2 is not, the remainder is not 0, so it is showing false. Then 2 divided by 2, the remainder is 0, so coming out to true. False, true, false, true, false, true, false, true. Now I can very well use all my operators just to demonstrate. Not x, so I should get exactly opposite. True, 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 true becomes false, 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 and all the 5 falses are becoming 5 trues. Similarly, I can talk about x and y. When both of them are true, this will evaluate to true. So look at this. Okay, the first one should be false. The second one should be true because here it is true. Here also it is true. The second one should be true. Here it should be false. The fourth one should be true because here x is true, y is true. So it is coming out to be true. All others. In the fifth one, y is false. And from the sixth one onwards, x is false. So all these should come out to false. Similarly, when I am doing x or y, the piping symbol is what I use. And now I could see any one of them true, it will return true. Only when both of them are false, it will come out to false. So in the first 5, because at least x is true, it is working out to true. And from the 6th onwards, 6, 8, 10, y is true. So they are working out to true. Only for 7 and 9, I see both x and y are false. That's the reason overall result is working out to false. So we can very well use these logical operators. Then we have a few more, right? We have a few more such kind of functions apart from and, or, and not. We also have a couple of functions called any and all, right? Any is, we can easily make out any and all. Any will return true if there is at least one which is true. At least one is true, any will return true, right? And all will return true if all of them are true. Let me test out. Let me create x, right? Let me create some x saying it is false, false, true. Now if you look at any of x, right? A capital any I can't use. I have to use small any. So any of x, it is true because at least one of them in x is true. But if I say all of x, it is working out to false because all of them are not true. But if I am assigning some y, let's say true, probably here we'll give some more calculation kind of stuff to do it much better. 2 multiplied by 3 equal to 6, right? And 3 divided by 3 or 3 divided by 2 not equal to 2. So let's say these are the two things that we are giving for y. And I want to know any of y. It's true because both of them, so this is evaluating to true. This is also evaluating to true. But if I am saying all of y, even this is true because both of them are working out to true. So any and all are also a couple of other features that can really help me as a part of the logical. So in the logical operation, just to summarize, I have to, I'm actually using important operators like and, or not, and or. Along with that, I am also using any and all, right? So that's how we get a basic understanding of the logical vectors that can be used comfortably in R, right?